All right, in this video, we're going to take a little closer look at how to manipulate literal equations. That's equations or formulas that are all letters or very few numbers. Because many times, well, especially in radio work, some of the more common formulas you might be dealing with are those for power, which kind of follow Ohm's law, as well as Ohm's law itself, and then there might be a couple of others. Okay, and I've already kind of covered this once, but I'd like to go a little more in depth. Let's start with Ohm's law. I always remember that it's voltage times voltage is equal to the current times the resistance. And remember, when you put two letters next to each other, the implied math operation here is multiply. Okay, so here's the general strategy in solving any equation that's all letters. Well, this equation or formula, that means the same thing, is already solved for V. If we know current and resistance, all we need to do is calculate and we'll get our voltage. But what if I wanted to know the current? It would be nice if I had an equation like this where it said I equals something. Well, we can use our algebra skills to create such a formula. The processes of algebra, as I've said before, are very mechanical, very repeatable. We're just moving things around by applying addition, subtraction, multiplication, or division. The only thing we really need to be careful about is that whatever we do to one side of the equation, we must do to the other. That's the golden rule of algebra. Whatever you do to one side, you have to do to the other. And that's actually the magic that makes algebra work. Okay, so I know what the resistance is, I know what the voltage is, so I need a formula that lets me get current. Well, we can use this formula. Let's put our focus on the I. We want to solve this equation for I. We're not solving for a value. We're solving for another equation. But the process is identical as if we were trying to find out what x equals. Okay? So, what's being done to this I? It's being multiplied by the R. This is multiplication here. So what we do, whatever operation is being done to our variable of interest, we want to do the opposite. If this is being multiplied by R, then let's divide it by R. But I must do it to both sides. R over R just cancels to 1. So now I get my equation. First one we had was V equals IR. And now I have one for I. I is equal to V over R. All right, let's do the same thing. This time we'll solve it for R. What's being done to the R? Well, it's being multiplied by I. So let's divide by I. Those cancel to 1, and there we are. Now I have an equation. R is equal to voltage over current. All right. Now this is a pretty simple equation, and all we have to do is divide by what we want to get rid of to leave the letter that we're interested in there, so we create a new formula for ourselves. But the principle is the same for any equation. Let's move away from electronics and do a geometry one. The perimeter of a rectangle is equal to 2 times the length plus 2 times the width. Now, let's say that I know what the perimeter is, I know what the length is, I don't know what the width is. So this is my variable of interest. What I want to do is I want an equation where I can plug in the perimeter and the length, and it will tell me what the width is. So I need to solve this equation for W. All right. What's being done to that W? Well, right close here, it's being multiplied by the 2. So I know at some point I'm going to have to divide by 2. But since we're doing things kind of in reverse order, that's how I remember this process, get rid of any adding or subtracting first. You kind of have to do a reverse PEMDAS, or order of operations. Get rid of any fractions, parentheses, and get rid of any adding or subtracting. Okay, so how do I do that? Well, let's just subtract 2L, but I have to do it from both sides. So I get P minus 2L is equal to, that goes to 0, 2W. All right, I'm still interested in my W here. So what is being done to it? It's being multiplied by that 2. That's the only thing left. Since it's multiplied by 2, let's divide by 2 to get rid of it. But I have to do both sides. That cancels to 1, and there's my formula. W is equal to P minus 2 times the length, all divided by 2. Okay, on your own, you might practice that for L. Solve it for L. We did W here. This process, by the way, will really sharpen your algebraic manipulation skills. They may not be that much fun to work on, but it puts muscles on your algebra skills. Okay. Lastly, I'm going to do a real complicated one. We know that the resonant frequency is equal to 1 over 2 pi times the square root of the inductance times the capacitance in farads and henries. Okay, let's say, well, the only pi, because it's a symbol, looks like it's a variable. Remember, it's just a symbol. That means 3.14 or 14159, whatever you like. Most cases, 3.14 is accurate enough. So this part of it is really just a number. But the variable that I want is C. I want to know that C. I want a formula out of this that tells me what, if I have a particular value of an inductor at a particular frequency that's supposed to be resonant with that inductor, what's the value of the capacitor I need? That's really the question we're asking. So we want to solve this equation for this C. Now, it's buried in a denominator. Whenever the variable of interest is in a denominator, get it out of the denominator. That's almost your first step, always. I say almost because I've not seen all combinations of formulas. Maybe there's a case where it isn't, but usually. So what we're going to do is multiply both sides of this equation by this whole denominator, 2 pi square root LC, and 2 pi square root LC. This cancels with this. Now, if you have adding or subtracting going on in your denominator, you could have some issues there. But most of the ones that we're dealing with don't. Okay, so now we have a new equation. 2 pi times the square root of LC times our resonant frequency, whatever that is equal to 1. That's what's left over here. All right, great. The next step then, where's my C? Well, it's still over here, and it's hooked up underneath this square root sign. But let's get rid of these other players. This term, the square root of LC, is being multiplied by both 2 pi and by the resonant frequency. So let's divide by those two things. We'll count 2 pi as one thing. 2 pi FR. And of course we have to do that over here. 2 pi F sub R. That cancels this out. This cancels out. And when we say cancel, it goes to 1. And 1 times anything is whatever the anything is. So now we're left with the square root of LC is equaling to 1 over 2 pi times the resonant frequency. All right. However, my variable of interest is still locked up underneath this radical, the square root sign. The way to get rid of a square root is to square. Squaring is the opposite of taking the square root, or square root is the opposite of doing the square. So if I square this, and of course I have to do that to both sides, this cancels this out, and I'm left with LC then is equal to the quantity of 1 over 2 pi resonant frequency squared. Nothing we could do to this. Well, we could simplify it a little bit. We could, 1 squared is still 1, 2 squared is 4, pi squared is whatever it is. But we'll just leave it in this form. C is still not by itself, but now it's from underneath that radical. It's being multiplied by L, so guess what? We're going to divide the left side and the whole right side by L. So C then is equal to the quantity 2 pi. I'm sorry, I didn't do got all excited there. Is equal to 1 over 2 pi resonant frequency, this quantity squared, and that's all over L. Now, we could get rid of that, simplify this compound fraction, but in order to do that, we need to get rid of this squaring first. But for all intents and purposes, this is a good answer. You could enter this in a calculator. You know, 1 over 2 pi, well, you could just put, you know all these values. The only value you don't know is this. So in your calculator, put this whole numerator thing in your calculator and then square it and then divide by L. And that will give you C. Okay, we're a little bit over time because that last, that's a lot of algebra going on there. But I wanted you to see how well these processes work. And if you do this enough times, you'd be surprised at how good your algebra skills become when you're sitting down and you're solving an equation in a normal way when you want to find out what x is. Okay, I hope that helps.